Good afternoon. My name is Hendrik Makaneta, and of course, I'm going to teach you grade 8 mathematics this afternoon, the 1st of July 2020. Please feel free at any time to ask any question at any time. If you feel that you want to chip in perhaps, just to ask a question, please feel free at any time to answer or to ask a question. Now, today's lesson is going to be
white gaming weight loss.
Right. I think that we need to mute everyone for now, and so that we, if you have a question, please feel free at any time to raise a hand, and then I will recognize you. You can be able to ask your question. Right. Today's lesson is going to be based on algebraic expressions. We will look at the examples as well as the flow diagrams for grade 8 mathematics. And you will remember that what is important, of course, is to realize that an algebraic expression indicates a sequence of operations that can also be described in words. You can describe the algebraic expression as a sequence of operations. In other words, you can multiply or add or even divide. All the 4 operations can work, and in some cases, they can be described with flow diagrams, as you will see in the next example. If you look at this example here, which I've just short screened there, if x is equal to 5, the expression 12 plus 3x means if x is equal to 5 and you are given the expression 12 plus 3x, this means you have to multiply that 5 by 3. So basically, you need to just substitute in this expression. So the expression is 12 plus 3x. And of course, if x is 5, then you multiply the 5 by 3 here. 3 times 5 or 5 by 3 gives you 15. And then you add the 12. So 15 plus 12 then will give you 27. So I want you to realize that without any waste of time, this does not mean that you add 12 and 3 and then multiply by 5. There are learners who sometimes make a mistake of doing this. When you have 12 plus 3x, they add 12 and 3. And the learner will say 12 plus 3 is 15. And thereafter multiply 5 by x. No, it should not be the case. Remember, this is what we call a binomial, which consists of a term there, which is a constant. 12 is a constant. 3x is not a constant. It depends on the value of x. So 3x is not a constant. It depends on the value of x. So x can change. When x changes, the value will change as well. The term 3x will change. If x is 1, then it will be 3. If x is 2, then it will be 6. You multiply 3 by the value of x. So I just thought this is how we need to start our lesson today. If you wish to say add 12 and 3, then multiply by 5, then this means that the numerical expression is going to be different. It means you are going to multiply 5 by 12 plus 3, which is not the case. Or 12 plus 3 times 5. So I want us to describe the sequences correctly and do the calculations correctly. You can tell that this is important. For instance, if you were to describe each of the sequence with an algebraic expression, the first one here I'm saying multiply any number by 10 and then subtract 5 from the answer and multiply that answer by 3. How are you going to multiply it? So any number can be x. So if I say multiply a number by 10, that number can be x. It's a variable. So and then you subtract 5 from the answer. So it means if I'm multiplying the number by 10, if that number is x, then you'll have 10 times x, which is 10x. Then you subtract 5 from the answer, 10x minus 5. And then you multiply the answer by 3. So it means you'll have open bracket 3 into 10x minus 5. I hope that it makes sense. This is the third expression there, which was in weights. Now we have put it in the form of an equation. We said multiply a number by 10. Let the number be x. So x times 10, and then you subtract 5 from the product. So it means you are subtracting 5. And then you multiply everything by 3. And this is how we have come to 3 open bracket 10x minus 5. And I hope that it makes sense that you can turn a number, the numbers that are in weights, then you can put them in the form of an expression. The second one is as follows. Subtract 5 from a number and then multiply the answer by 10 and multiply this by 3. Subtract 5 from a number and then multiply by the answer by 10 and multiply this answer by 3. So let the number be y. So if you subtract 5 from a number, it means if that number is y, then you have y minus 5. And then multiply the answer by 10. So you multiply the answer by 10 and multiply this answer by 3. Then you multiply the answer by 3. So you can see that if we are given a problem in weights, you can actually put it in the form of an expression, what we call the algebraic expression. So if we say to you, subtract 5 from a number. Remember, when we say a number, I've not given you any specific number. So that number, it can be any number. So how do you allocate any number? You can allocate any number by putting a variable, because x stands for any number. It can be 1, 2, or it can even be a negative number. So if you subtract 5 from a number, then it means that number, if that number is y, then it's y minus 5. And then you multiply the answer by 10, then you multiply by 10 there. Then multiply this answer by 3, then you multiply everything by 3. So 10 times 3 is 30. So you can see your algebraic expression is going to be 30 open bracket y minus 5. And this is the algebraic expression. So it is the relationship between variables and numbers. So it's a relationship between variables and numbers. Without any waste of time, I'm just going to zoom directly into these particular expressions. I want us to evaluate each of these expressions if we are given the value of x there. So you can see that we have about 5 different expressions. And then the value of x is 10. Now I want us to solve or evaluate the expressions by using x, the given value of x, which is 10. We have 5 different activities, as I've already indicated. The first one is 200 minus 5x. followed by 5x plus 40, 200 minus 5, both of which are in bracket, and then you multiply that by x. So that is a binomial inside there, 200 minus 5. And then the next one is 5 open bracket, x plus 40. And the last one is 40 plus 5x. I want us to look at the expressions and find the value of each expression using the given value of x, which is 10. So the value of 10 there is given for x. And of course, I want us to use this value to evaluate each expression that is given below. Can we proceed to evaluate each? Can we proceed to evaluate? Let's evaluate each. Let's just evaluate each one of those. Now evaluate each of these expressions if the value of x is 10. If you have a pen and a paper with you, please go ahead. And if you want to share your answer with us, please feel free at any time to share your answer with us. Feel free at any time to share your answers. Right, I'm just going to proceed with the first one. Asanda, if you want to say something, please feel free at any time. I hope that you have a pen and a paper with you and you are busy solving this as we speak. Right, 200 minus 5x, this is an expression on its own. And what is required here is simply to use x value there, which is 10, and then we need to substitute this the value of 10 there on the expression x. So the first things first, we have 200 minus 5x. And since we know that x is 10, where there is x, we are now just going to substitute x with 10. We know that the value of x is 10. So where there is x, we will put 10. Now the expression will be as follows now. 200 minus 5x, you can see that where there is x, we have now put 10. So you open the bracket, and then you put 10 and close your bracket. This means you are now going to multiply 5 by 10. So remember, 200 and then minus 5 times 10 will be 50. So you can see that 200 minus 50 will give you 150. So the value of this expression will be 150. So that will be the correct value of the expression. So in A there, the expression is 150. So we've managed to solve A. Remember, don't confuse the two. Can you see that A together with a C, they look almost the same, but they are not the same. I'm sure you can tell that these two look the same. You have 200 minus 5. You also have 200 minus 5 there. But look at the x value. In this case, the coefficient of x is negative 5. But in this case, the coefficient of x is 200 minus 5, all in bracket. So make sure that you notice the difference because the values will also not be the same. The value of the expression, once you evaluate the two expressions, you will not get the same answer. The same goes for B. If you look at B, you have 5x plus 40. And if you look at D, you have 5 into x plus 40. And alternatively, you also have 40 plus 5x. I want to test your knowledge here. 40 plus 5x and 5x plus 40. Are these the same? We will come to that. But for now, we have just solved 200 minus 5x, and we said that the answer is 150. How did we find 150? We simply substituted the value of x, which is 10, and 10 times 5 gives us 50, and 200 minus 50 is 150. So the value of this expression, A, is 150. That's the value of the expression. Now I want us to proceed with the second one, which is B. We are given 5x plus 40. I want us to use, remember, when we evaluate these expressions, we are using x, value there of 10. So all that you need to do really is to now substitute 10 in the expression, and then you can evaluate or you can calculate the value there of the expression. What will be the value of this expression if x is 10? I'm talking about B. We are now at B, 5x plus 40. That is where we are. We have just done A as an example. And of course, we found the answer to be 150. That is the value of the expression. Perhaps let's do B as an additional example, and then you can proceed to take it from C. I'm going to do a B for you as another example. We have now 5x plus 40. Remember, the value of x is 10. So where there is x, we are now going to put 10. So how do we calculate that? You can tell that in B as well, 5x plus 40 is the expression. And as I've already told you, the value of x is 10. This is what we know. It is given in the exercise. So where there is x, you'll put 10, or you simply substitute. So this expression now becomes 5, open bracket, 10. Remember the value of x is 10. So you'll have 5, open bracket, 10. Then you close your bracket, plus 40. And then 5 times 10 gives you 50. I'm sure you agree with me. And 50 plus 40 gives you 90. So this is the evaluated expression of B. The value of the expression will be 90 if and only if x is equal to 10. If the value of x can change, surely the value of the expression will also change. But for now, the value is 90 because the x value is 10. I hope that you have looked at the two examples, and I hope that they make sense. Let us now carry on with the next one, which is now C. Remember, we have done A, and we found that the value of A is 150. All that you did was to substitute 10 there, and 5 times 10 is 50, 200 minus 50 is 150. Now the question that I have for you, will the value in A be the same as the value in C? Given that you have 200 minus 5x, and in this case you have got 200 minus 5, and then x outside the bracket. Are you going to have the same answer for A and C? That is the key question. But for you to find out whether you have the same answer or not, you need to work it out. And like I said, I hope that you have a pen and a paper and you are busy working it out so that you can find the final answer. Khumulemo, let me go to Khumulemo now. Khumulemo, I hope that you have a pen and a paper with you. And as we speak, you are working it out. Erin, anyone at all? Right. We are now going to proceed to solve the last one, or the third one rather. So it's 200 minus 5, and then you have x. So the value of x is 10. You will have to substitute the value of 10 there. And of course, 200 minus 5 will give you 195. That is what you have, 195. And then you'll have to multiply that by the value of 10 there. So in other words, this is how you'll proceed with the C. you'll have 200 minus 5, which is 195. And remember that the value of x is 10. So you put your 10 there, that's how you substitute, and 195 times 10 will give you 1,950. So can you see that the expression there, or the value of the expression in C, is different from the value in A. In A, you found 150, and then in C, you have 1,950. That is for the simple reason you need to sort out your bracket first. In other words, you need to calculate now the contents of your bracket. Remember, these are the like terms. 200 minus 5 definitely will give you 195. And then 195 multiplied by 10 will give you 1,950. So that is how you solve this expression. And then you can proceed to do D. In D there, you have 5 open bracket x plus 40. And then, of course, you are given the value of x, which is also 10. Can we have a volunteer to substitute the value of 10 in this expression D? Is there anyone who wants to substitute 10? If you have a pen and a paper with you, please substitute the value of 10 there in the expression in D and tell me what do you get? What is the answer that you get? What should be the answer that you get when you multiply or when you substitute x value there of 10? Right. The answer that you get, obviously, you follow the same procedure as we have done in the first category there. 5 into x plus 40. If x is 10, then it means you'll have 10 here. 10 plus 40, which is 50. And of course, 50 times 5 will give you 250. That is what we have. So in D, you have 5 open bracket x plus 40, and this becomes 5 open bracket 10 plus 40. Remember that the value of x is 10, so if you substitute it, you get 10 plus 40, which is 50. And 50 multiplied by 5 is 250. So that will be D, or that will be the value of the expression in D rather. And the last one was E, which is 40 plus 5x. And I've asked a question earlier on, that are the two values the same, B and E? 40 plus 5x, is that equal to 5x plus 40? Are they equal? Yes, they are. 5x plus 40 is the same as 40 plus 5x. You just swap the two, and then you still have the same value of the expression. So the two expressions have to be equal. Remember, what was the value of the first expression there of B? In B, we found that if you substitute 10 in the value of x, then you'll have 10 times 5, which is 50, and then 50 plus 40 is 90. So 90 was the final answer there. So B and E will definitely be the same. They will definitely be the same, because in E as well, you can see this is 40 plus 5x. So you have just swapped the two. So this becomes 40 plus 5 open bracket 10. So 5 times 10 is 50, and 50 plus 40 is 90. So you can see that B and E are the same. Now, without any waste of time, I want us to look at the definitions of algebraic expression or algebraic expressions. We are at times told that an expression with one term only, if you have an expression with one term only, like 3x squared, this type of an expression is called a monomial. This is what we mean by a monomial. A monomial is an expression with only one term. Now, an expression with two terms, like 5x plus 4, is also known as a binomial. Now, a binomial is an expression which consists of two terms. That is a binomial. The third one there, an expression with three terms, like 3x squared plus 2x plus 9, is known as a trinomial. So I've spoken about three expressions or three algebraic expressions. And the first one is a monomial followed by a binomial, and the last one is the trinomial. And the monomial is an expression with only one term. So if you have any expression with just one term, then that expression will be known as a monomial. Whereas the expression with two terms is a binomial. And thirdly, you also have an expression with three terms, which is known as a trinomial. So those are some of the expressions that I wanted to talk about. But at the same time, how do we use our variables? We use x to represent a variable. In this monomial 3x squared, you can see we have 3 next to the x squared there. This 3 is known or is also called a coefficient. We call it the coefficient of 3, the number that is just next to the variable. The variable in this case is x squared, and the number just next to the variable is known as the coefficient. So in 5x plus 4 and 3x squared plus 2x plus 9, the numbers 4 and 9 are also known as the constants. Why do we call them constants? Because these are numbers which cannot change. They cannot be changed by the value of the expression. So 4 stays the same. Even in this case, 9 stays the same. The only expressions or the only terms, in fact, that can change depending on the value of x are 3x squared and 2x, and in this case, 5x. Those terms will definitely change. Those terms will definitely change. Those are the terms that will change. Let's give Lin. Yes?
Sir, can you please turn to the last page, the last slide, please?
The previous slide. Okay, thank you.
Yes, the previous one. Thank you, sir.
Okay, sure. Okay, great. Right, Lynn wants us to proceed to the previous slide, which talks about the algebraic expressions, and this is how I was explaining the expressions to you. It's very important for you to understand the different expressions in mathematics. This will certainly go a long way in your career in mathematics as you proceed. It stays the same, it doesn't change. A monomial is an expression with only one term. Example is 3x squared. And an expression with two terms, like 5x plus 4, is known as a binomial. And an expression with three terms, like 3x squared plus 2x plus 9, is known as a trinomial. So those are the trinomials. And of course, you can use these different terms at any time. I just want you to remember the trinomial, binomial, and monomial. Those are the 3 terms that we will be working with. Because I'm going to give you an activity shortly based on the following expressions: the monomial, the binomial, and the trinomial. So you need to be able to recognize a monomial. Look at this monomial 3x squared. It consists of a coefficient, which is 3 there, and a variable, which is x. So the variable there is x, and the coefficient is 3. The number just next to the variable is known as a coefficient. It's always on the left-hand side. We start by writing a number first, and then the variable. 3x, you don't have x3 in mathematics. You don't have anything called x3. You will always have 3x. Unless you are talking about x cubed. Yes, you have x cubed, x to the power of 3. I know there are some learners who call it x3. That is not x3, that is x cubed, or x squared. Some learners call it x2. We don't have x2. We only have 2x. And we have x squared. Right. I hope that the definition of the different expressions make sense. I hope that you recall the basic explanation of a monomial. A monomial simply means one term, an expression with one term. Whereas a binomial is an expression with only 2 terms. Trinomial, an expression with 3 terms. And we are talking here about the algebraic expressions. Remember, the algebraic expressions mean it's a combination of numbers and variables, which are separated by different operations, be it positive, negative, or addition and division and multiplication as well. So it's addition, subtraction, division, multiplication. So it can be any of the operations. They are applicable in any algebraic expression. Now I'm going to give you an activity right now. I'm going to give you an activity in the form of a table. And before I do that, let me finalize the explanation, which I was about to wrap up in this lesson. We use x to represent a variable. Not only x, but it can be any symbol. Sometimes you can use y or z or a, b, c, any letter is a variable. And then as long as it's not a number, you know, we use x to represent a variable. So it can be x or b or c or f or g. It can be any letter. Any letter can represent a variable. Now, in this monomial 3x squared, the 3 is known as the coefficient. That 3 there is also known as the coefficient. And of course, in 5x plus 4, as well as 3x squared plus 2x plus 9, the numbers 4 and 9 are known as constants. Now, these are constants because constants simply means that they will not change. Something that is constant doesn't change, it stays the same. So 4 stays the same, it doesn't change in its value. 9 will also stay the same. But if you look at other terms like 3x squared and 2x and 5x, those terms can change if the value of x changes. Remember, the value of x can be any number. So if the value of x, for instance, is 1, then this expression, this term is going to change. It will be 5. If x is 2, then that term will be 10 because 2 times 5 is 10. Can you see that? But it doesn't matter whether x can change 100 times or 1,000 times. The value of 4 will remain the same. It doesn't change. Even in this case, you can change all the values of x, but this term will never change. It is 9. It is constant. So we say anything or any number that does not change in value, it's called a constant. It doesn't change. It remains the same. Now, I want us to move now to zoom directly into this table, which I want us to complete. And the table consists of an expression, the type of expression, the symbol, the constant, and the coefficient. Now let's look at the first one there, the expression. X squared plus 6x plus 10. That is our expression. And then if we want to know what type of expression is this, you can see that there are 3 terms there. X squared is a term on its own. 6x is also another term. And 10 is another term. So how many terms do we have here? We have 3 terms. It's x squared, 6x, and 10. That is why we call this expression a trinomial. We call it a trinomial because it is an expression with only 3 terms. And what is the symbol that is used? The symbol that is used to represent the variable in this case is x. Hence, we have answered the question as x. And the other question says, what is the constant? Is there any constant in the expression? Yes. The constant is 10. Can you see 10 there is the constant? So we write 10 as a constant. What is the coefficient of the second term? The second term here is 6x. And so what is the number that is just next to the variable? That number is 6. So the second term is 6x. The coefficient there is 6. The coefficient of 6x is 6. So we have answered all the questions in relation to the first expression. That is what we have done now. Now I want to give you an opportunity to answer the different questions based on the second expression here. The second expression is 6s cubed plus s squared plus 5. Now I want anyone to tell me what type of an expression is this. So you need to put it here in this box and tell me the symbol, the constant, and the coefficient. But the first learner who is going to speak now must tell me what kind of an expression is this. Is this a monomial, binomial, or trinomial? And please give me the reason for your answer. Is this a monomial? Is this a binomial? Or is it a trinomial? Lynn, let's hear from you. What kind of an expression is this? Is this a monomial? Is this a binomial or a trinomial? Yes, Lynn? Please go ahead, Lynn.
Yes, sir. So it is a trinomial because it has 3 terms.
Exactly. It is a trinomial because it has 3 terms. So there are 3 terms, and so the first term is 6s cubed plus 6s plus s squared plus 5. So there are 3 terms. What is the symbol that is used there in the expression?
S.
The symbol is S.
Yes.
Is there any constant?
The constant is 5.
Exactly. The constant is 5. So we can see that the value of 5 will not change. It's not affected by the different values of S. So it doesn't matter what the value of S is, but 5 remains the same. It doesn't change. Right, the last question there on the same one is the coefficient of S squared. What is the coefficient of S squared?
Coefficient of S squared.
meaning that the number that is just next to s squared. What is that number?
Sorry, sir. Which number?
Do we have a number next to
Oh,
what?
6.
Not s cubed. The one that you spoke about is
Yes,
the first one.
6.
6. Yeah, 6 is the coefficient of s to the power of 3, meaning s cubed. But I'm looking for the coefficient of s squared, this value, the middle term.
The coefficient of s squared.
Yeah, you are right when you say 6 is the coefficient of s cubed. That's correct. But I'm now looking for the coefficient of s squared. What is that coefficient?
I don't think there is a coefficient for s squared.
Okay. All right, let's go to Lesedi. I see Lesedi's hand is also up. Lesedi, please go ahead. Lesedi, please go ahead.
Sir?
Yes, Lesedi?
So the,
What is
the coefficient is 1.
Exactly. The coefficient of s squared is 1. You know, we always have that invisible one that we don't write in, and this goes to the rest of the class. There's always that invisible one. We don't write 1, but we know it's there. Just like when you have a plus b, you know that it's always 1 there. We just don't write 1a and then 1b. You know, we just write a. All right. It's just like when you, yes, just give me, just like if you say, give me an apple, you see? We know it's, if you say an apple, you are referring to just 1. But you can say 2 apples, 3, and so on and so forth. But an apple, we know if it's an apple, then it's just 1. So the same goes for all the symbols. S squared is just 1. So you don't write the 1, you don't say 1 s squared. Right. The next one, we are done with the second expression. We are now proceeding to k over 3 plus 12. We are left with only 2 for the day. K over 3 plus 12. What is the expression there? What type of an expression is this? What type of an expression is this? Is this a monomial? Is this a binomial or a trinomial? I'm talking about k over 3 plus 12. What type of an expression is this? Yes, Lucidi? Did you forget to put down your hand, Lucidi? Or do you want to say something again? All right. The type of expression in this case is, this is a binomial because it consists of only 2 terms. The first term is k over 3, and then the second term is 12. So this is a binomial. What is the symbol that is used in this particular instance? You can tell, surely you can tell me what a symbol is. This should be easy. What is the symbol? Buhle? What is the symbol that is used there? The symbol is K. So K is our symbol. What is there any constant? Yes, there is a constant. What is the constant? The constant will be 12. So you can see that our constant there is 12. And then is there any coefficient of the first term there? Yes, there is. The 3 is in the denominator, then there's 1 next to K there. So it means the coefficient of K is 1 over 3, just a third. A third, it's the coefficient, also known as 1 over 3. That is the coefficient of K. Right, the last one, 4p to the power 10. What type of an expression is this? This is? Right, I think I must also go to your chat box quickly. Let me see if there's any thing that you have said there. I know that some of you may have went and typed in the chat box. What is the coefficient there? The type of expression in this case will be, this is a monomial. So this is a monomial. And of course, we are talking here about a monomial. Is there any constant? There is no constant, all right? There's no constant in this case, so there is no constant. I'm trying to move over to your chats now, just to see, of course, if there's any. And then the next one will be the symbol. What is the symbol that is used? What is the symbol? The symbol that is used in this case is it's P. And what is the coefficient of P to the power of 10? The last one. What is the coefficient? The last one. Right, the last one, the coefficient will be, it will be 4. The coefficient of P to the power of 10 will definitely be 4. So this is what we have in as far as the topic is concerned. I apologize that I could not be able to respond to all the chats in this case, but I'm looking at the time that we have now. We're sitting at 12:47. But let me take this opportunity to thank all the learners who have participated also in the chat box, to say that we will probably engage more tomorrow as we proceed with our lessons. But this lesson was brought to you by the STEM Digital School. And of course, we can always meet again tomorrow. Let's meet tomorrow again just to carry on with our lesson on algebraic expressions. And of course, if you have any questions, please feel free at any time to direct them to the school, STEM Digital School at africa10geeks.co.za. Until we meet again tomorrow, thank you very much indeed.